Welcome to our next and final video 3 out of 3, still solving systems of linear equations, but this time, and probably the most challenging time, is elimination. Now, elimination is a good tool to have, which is why I'm showing you. But I will say elimination tends to be the difficult one out of the three because of the varying in ways to do it. So again, we still have a system. We have solved the linear system by using elimination. Now, how elimination works is exactly how it sounds. I told you in the previous video that you want to try to make it to where you have a single variable to work with, so that way you can work to isolate one thing at a time. In graphing, you isolate your y, you plug it on your graph, find where they intersect. In substitution, you change the value of one of them to the other, solve, and then you can plug in to get your final answer. And then in elimination, it's all about, can you identify opposites? So if we look at the first system, we have 4x minus 3y, and then we have, I didn't finish that. 4x minus 3y equals 5, and then in the second one, it says negative 2x plus 3y equals negative 7. We have opposites right here. We have a negative 3y and a positive 3y. What we as mathematicians can do with that is cancel the zero pairs out and get rid of that y temporarily. It doesn't go away, but it makes it to where I am able to solve this like a normal problem that's just stacked on top of each other. I have 4x minus 2x. That's going to leave me with 2x equals 5. Oh, sorry, I'm covering that up. 5 minus 7. That would give me a negative 2 value. So see, we got rid of those y's because they were already set up to be each other's opposites. So that means they zeroed each other out. Now I'm able to simply solve for x. Divide by 2. X equals negative 1. Now, if your question said, what is the value of x? You would already be done. You wouldn't have to go through all of the extra stuff. But I, of course, am going to challenge you. I want you to solve for the y. So solving for the y kind of goes back to that substitution part where you do have to plug in. And we're going to plug into one of the original equations. And again, I always just say pick the easier one. The easier one, in my opinion, is the 4x minus 3y equals 5. And the reason I say that one is because the coefficient in front of x is positive, and I just like positive numbers. So now I can plug in 4 instead of x, the value we got, which is negative 1, minus 3y equals 5. Then solve. Negative 4 minus 3y equals 5. Add 4 to both sides. Negative 3y equals 9. Divide by negative 3. I feel like some of y'all are like, Miss B, this is so much. It's not, I promise. And then negative 3. I just think math is so cool. You are able to take two things that look completely insanity and tell me so much about them in two separate, not steps, but parts. And that's just so neat to me. So now, what you're able to tell me is that this will intersect at negative 1, negative 3. making that a one solution. So I'm going to kind of graduate you from writing one solution because, as you can tell, you got one answer, therefore one solution. Oh, my lights went off. 1 second while I turn those back on. So sorry about that. My lights went off. I've been sitting here too long. All right, so now we're going to move on to example number 6. Now, again, how elimination works is, do you have 0 pairs that you can cancel out? Let's look at it. We have 7x minus 2y equals 5. And then we have 7x minus 3y equals 4. So I can see that they're hinting at these 7x's because there's 2 of them. However, they're not 0 pairs because they're both positive. The part that makes elimination difficult is you can manipulate the system. And what I mean by manipulate the system is I can actually turn one of those 7x's negative. So here, if I can get my words right, here's how it works. I'm going to change the second one. I'm just choosing the second one. You don't have to do the second one. I just always personally like to change the second one if I have to because it's on the bottom, okay? When I say change it, I'm going to put it in parentheses. I always put what I'm changing in parentheses so that way I know in my head, oh, this is what I'm manipulating, okay? I know that in order for me to say that those 7x's are 0 pairs, one of them has to be negative, so I'm simply going to multiply everything in there by a negative 1. And watch what happens when I do that. I'm going to rewrite the system. I'm going to rewrite 7x minus 2y equals 5. Now, by manipulating the second one, by multiplying it by negative 1, watch what happens. Negative 1 times 7x, negative 7x. Negative 1 times negative 3y plus 3y equals negative 1 times 4, negative 4. You manipulated your second linear system equation by multiplying the entire thing, everything in that parenthesis, by negative 1, and you created your 0 pairs, and you were able to eliminate them. So that is the part about elimination that is a little bit challenging, is sometimes you have to manipulate your system, and that is how you would accurately do it. Now you are able to solve negative 2y and positive 3y, create y, just a single one, equals, and 5 minus 4 is 1. So you were able to stop. You didn't have to do anything further from there, which is why some people prefer elimination. You just have to be comfortable with the manipulation part. Okay, now your handy dandy plug in to solve for the other one, because I ain't gonna let you get off easy. I want you to solve for the other one. Pick the one you think is easier. I'm picking on the bottom one. I'm gonna stick with the bottom one. 7x minus 3y equals 4. We got y equals 1. I'm gonna rewrite this whole system here with 1. So I've got 7x minus 3 times 1 equals 4. Then I'm going to multiply it out. 7x minus 3 equals 4 because 3 times, negative 3 times 1 is negative 3, and then that 4, add 3 to both sides. 7x equals 7. Divide, divide, cross out, x equals 1. So now you can accurately say that these intersect at 1, 1. And these are a 1 solution. Okay, I want you to attempt number 7. Remember the goal, or example 7. The goal is to have 0 pairs that will allow you to eliminate. Try example 7 and come back. Welcome back. I hope you noticed it did say use elimination. Okay? Now, when you look at this, you go, oh my gosh, Miss B. There is nothing 0 pairs, and they're not even hinting at anything. I hope from example 6 you understand that you can create the 0 pair. The part that makes this difficult is understanding which one to choose. One person might not change the same thing. Me personally, I see that 4x plus 3y equals 8. And then I see x minus 2y equals 13. In my mind, I think, oh, that x can be changed to a -4. Now, how I do that is very selective. I gotta put it in parentheses because I'm changing it. And notice again, I'm picking on that bottom one. That's the one that I'm changing, okay? So, I want that x to turn to a -4x because I want it to 0 out. So, I'm gonna multiply the entire thing by -4. So, I've gotta rewrite my system. I'm gonna draw my little squiggly lines that took me years to master. 4x plus 3y equals 8. Then I'm going to distribute that -4. -4x plus 8y equals, and then 3, oh, I'm so sorry. I can't talk. -4 times 13 is a -52. Now, don't think I'm just some super genius, even though I'd like to think so. I did multiply that off camera. Okay, so now I have a 0 pair situation, but I do want to shed some light here. You could have turned either the 3y or the 2, oh, no, actually, no, you couldn't. Just kidding, I'm getting ahead of myself. No, the 4x was the smartest way to go simply because the coefficient was 1 and that's easily manipulatable, okay? What I was just about to say goes into example 8, which we'll get to in just a minute. I'm so sorry, got ahead of myself there. So now, what we can do is get rid of the 0 pairs. So now I'm going to be left with 3y, 8y. Draw my little line underneath here. Yeah, draw my line. 3y, 8y, create 11y equals 8 minus 52 is a -44. Divide. All these steps. I think it's so fun. Algebra to me is like a puzzle. I'm like, man, how am I going to make these puzzle pieces fit? Look at us. We got our y. We got our y as -4. I challenge you to find the x. Ah! I draw my pen. Sorry. We're going to plug in right here, and you choose. I've been picking on that bottom one, but let's just do the top one and see if we can get something. 4x plus 3y equals 8. But instead of y, I can replace it with what we got as the value. So 4x plus 3 times -4 equals 8. So that leaves me with 4x plus, oh, not plus, minus 12, because positive, negative make negative, equals 8. Add 12, add 12. 12's cancel. 4x equals 20. Divide by 4, divide by 4. X equals 5. Perfect. So now you'll be able to tell me that they intersect at 5, -4. And just like that, you have solved another system. Now, when you get to example number 8, notice it says elimination, but I want you to notice that none of them have a coefficient of 1. You have a 2x plus 3y equals 12, a 3x minus 5y equals 37. In one of these cases, and again, this is why I say elimination can be difficult, you're gonna have to manipulate both. You can manipulate both. It's the strangest thing to me, but you can do it as long as you are consistent with what you do. So, when I look at 2x plus 3y equals 12 and 3x minus 5y equals 37, I think, which one could I manipulate to have the lowest possible coefficient and that both of them have this number in common? And in my mind, I'm thinking I want to turn this to a 6x and this to a negative 6x because I can cancel out two 6x's if one of them is negative and one of them is positive. Now to do it, I have to be strategic. In order to turn 2 to 6, I have to multiply it by 3. In order to turn 3 to 6, I have to multiply it by 2. But because I need it to cancel a zero pair rule, it's going to have to be a negative 2. So, rewrite your system. Oop, that one was not cute. 3 times 2x is 6x. 3 times 3 is 9y equals 36. And then your bottom one, negative 6x plus 10y equals negative 74. So again, this is why I say elimination can tend to be difficult, especially if you forget that distributing piece of multiplying every single thing in the parenthesis. So at this point, I want you to pause the video and I want you to attempt on your own. Welcome back. Hopefully you got through it. Let's see if you got the right answers. 6x's are going to cancel. I'm going to be left with 19y equals negative 38. 1738a. Haha, you're a real one if you know what I just said. Equals negative 2. Perfect. So I got the value of y. I challenge you again to get the value of x. You do that by plugging in. So plug in. Pick a random one. I personally don't care. Let's just go back to me picking on the bottom. 3x minus 5y equals 37 here. So now I'm going to plug in. I got 3x minus 5 times negative 2 equals 37. 3x plus 10, because negative and negative make positive, and 5 and 2 is 10, equals 37 minus 10 minus 10. 10s are going to cancel. 3x equals, we're almost done, y'all. My divide 3. X equals 9. There we go. And now you can finally tell me that they intersect at 9, negative 2, and that is a one solution answer. So at this point, hopefully you are comfortable with at least one of the 3 methods. Graphing, if you have a graph and you're really good at slide divide, that would be my way to go. Substitution, if you're really good about replacing, solving, and plugging in. And then elimination, if you're good at recognizing patterns and understanding what you can and cannot manipulate. Alrighty, y'all. Bye.